All right, guys, good afternoon. This will be the video for the reflection and refraction experiment. Uh, in here, you will be investigating the reflection of light and the refraction of light, part two. Part one is quite simple. It's just basically reading the values in the app. Part two, however, you have to do a couple of calculations and a plot. It's quite easy to get the data for the angles, but you have to be careful with the way you do the calculations. You can do it in Excel, since you have to do the plot in Excel, but let's go over it. With reflection of light, you're given the angle of incidence here. And in the application, you can basically move this, and the protractor will tell you the value of the angle. So for example, 0 degrees, like that, so no reflection. If you go here, you have 5 degrees, 10 degrees, 15 degrees, and then you can keep going until you get to 90 degrees here. That's how you do part one. You read the incidence and reflection. Now, the angle of incidence, for example, if I want an angle of incidence of 30, that will be it. It's this angle here. And the angle of refraction is this angle here. Incidence and refraction order. You can clearly see the reflected ray order. It's refracted. We're going to go over that in a bit. You have to answer a couple of questions and then talk about or explain what relationship is between the angle of incidence and the angle of reflection. I'm sure when you guys start doing this lab, you will have spoken about this in the lecture. So it should not be very difficult to answer, all right? Should be actually pretty straightforward. The law of refraction, or Snell's law, is here. So the objective in this part is to find the index of refraction of water. Now it's here. That's your theoretical value. The experimental value, you will get it from finding different angles of refraction by changing the angle of incidence. So the angle of incidence goes from 0 to 80 every 5 degrees. And you can create a table in Excel. I just put a few values here. But you go from 0 to 90 degrees. And for each angle of incidence, you can find the angle of refraction by, again, moving this. So 5 degrees is here. And you can see that the angle of refraction is about 3.5 degrees. 10 degrees, and you're getting about 7 degrees. So let's start writing the data, right? This is kind of 0 is 0, sign of 0 there. So for 5, we go 3.5. For 10, we go 7. For 15, oh, 5, 10, 15. Yeah, 15 here. I got about 10 degrees. So it's fine. It's not going to be linear, so don't worry about it. For 20, I get about 14 degrees, 5, 10, so 14 there. For 25, I get about 28. Wait, that doesn't make sense. Let's see this. Yeah, this is around 5, 10, 15, 18. Has to be less than the amount of incidence because the index of refraction of air is greater than is less than the index of refraction of water. So that will give you a lower angle of refraction, of course. And then for 30 incidents, I get about 5, 10, 15, 21. Okay. You can use a calculator for this. So let's say you want to find the sine of 5. So you go 5 sine, and you get it. If you want to do it in Excel, which would be more efficient, you would do equal sine of the angle multiplied by pi over 180. It's the same value I got here, right? And if you go all the way down, it gives you the values. And as we know, sine of 30 is 0.5, so that's we can do same with this, equals to sine of this angle. Now, why am I multiplying by pi over 180? Because Excel only reads values of radians. So you have to do that. You have to do that. Okay. The lab tells you that you need to draw, you need to plot sine of I over sine of R. Sine of refraction in the x-axis, sine of, yeah, because sine of I over sine of R will give you the index of refraction of water. N1 is equal to 1, this value here, because that's air. So sine of incidence over sine of theta refracted will be the index of refraction, the experimental index of refraction of water. So I don't have enough values, but let's see what I get. So what I will do is I will move this here and this one here. You guys have been doing plots this semester, so it shouldn't be that difficult. And there you are, I get a nice sort of linear plot and add axis titles, trend line, go to options and make it so I can see the equation. 1.38. The theoretical value is 1.33. And then you can answer the questions or answer this question basically. So it's a very simple lab again. I don't think you guys will have any issues. If you have issues with the graph, remind that you can send me an email. Remember, you can send me an email or a message through Canvas. And we can do online meetups or in-person meetups as needed. Okay? That's it for this tutorial lab. Make sure you follow the instructions and you should be more than fine to complete it. Okay? So go through the video again and make sure you start working on this lab as soon as possible. Have a nice rest of your day, guys, and I will see you guys later.